Welcome to Video Bytes. With me today is Stefano Gridelli from NetBeez. NetBeez is a network observability company, network monitoring. Stefano, welcome to Video Bytes. And if you would, give us the elevator pitch, the 10,000-foot overview of what NetBeez is all about.
Yes, hi, Ethan. NetBeez is a real-time network performance monitoring solution that runs end-to-end tests of network infrastructure, whether it's on-prem, cloud, or remote.
Okay, now I'm somewhat familiar with the NetBeez solution. I've worked with it a little bit in the past. If you would you, I know you've got a slide with some definitions for us. Would you bring that up? Because that's important just so people understand what we're talking about as we go through the demo.
Yeah, definitely. That I think can help. Yes, so the agent are the most important part of NetBeez as they are the units that perform the network monitoring, not the server. I want to remember that. And the agents can be hardware or software network monitoring appliances that run across a distributed network tests. Can also be software clients that are installed on end-user systems, for instance, for work-from-home users.
Oh, including switches, it looks like. So I could put this on like my Cisco or Extreme switch or something.
Yeah, correct. So we support Docker and VMs, and most of the modern routing and switching vendors now support them for application hosting. So we have integrations, for instance, with Cisco or Extreme Networks.
Okay, so we've got agents in all sorts of form factors. What else have we got?
And then from agents, we go to tests. Tests are run by agents installed in different network locations. And tests can be real-time, such as ping, DNS, and HTTP to have a very good granularity on network performance, or it could be scheduled tests such as hyper throughput test or network speed test for download and upload. And these run more relaxed according to a user schedule.
Got it. Okay.
Tests then generate metrics, which is the most important thing, as we can collect information in real time from all our network locations and users about round trip time, packet loss, jitter, MOS, and so on. So you name it. And these are the building blocks, very important to be proactive, but also to have data to troubleshoot, with data and not with opinions, right?
Well, this is interesting the way you're breaking out the metrics. It's all the components that make up a transaction. So I'll know if it's my DNS resolution time that's adding a lot of latency as opposed to network transport time.
For instance, exactly. So
Yeah.
It really helps you to understand is a network, an application issue, or a DNS issue, for instance. Correct. The metrics then can generate alerts. Alerts allow you to be proactive. Alerts allow you also to enforce SLAs with predefined profiles, such as up-down or a performance baseline, where we compare a short-term moving average with a long-term, or a performance watermark, which is like an SLA type of test. I can really be alerted when there are conditions of network degradation, such as packet loss, round trip time, or download or upload speed. Very important.
Okay, so the only thing that scares me about alerts is that they can be very noisy. Is there a way to handle noisy alerts?
Yeah, and that's why we introduced the concept of incidents. And incidents aggregate alerts under an agent or a target. So to make it very simple, if an agent is throwing a bunch of alerts, most probably there is a network issue at that location, versus if a bunch of agents are having issues contacting a specific SaaS application, then those alerts aggregated within the target will open a target incident, which with this incident, then we can trigger third-party action on ServiceNow, webhooks, or other type of notifications such as email and so on. So that's really the signal that a NOC or a help desk team wants to receive to be alerted.
Okay, so now we need to move. You got to show me the dashboard now. Now I get it. I get the definitions. I know where we're coming from, and the next thing you got to show me is the dashboard because I want to see this thing in action.
Yeah, absolutely. So here is a small demo dashboard, meaning that we don't have a lot of agents for this demo, but Alisa gives a good overview of what you can expect from NetBeez. I'm going to skip the bathtub where you see the 9,000 feet view into your network with agent incidents, target incidents, or Wi-Fi incidents in the case of Wi-Fi appliances. In the agent view, that's where you really manage all your agents. As you can see in this lab, we have different type of agents. They can be VMs, they can be Docker. We also have external agents to have a perspective from a cloud service provider against an app. We want to remove any single point of failure in our monitoring, and so on. So in this case, this is a VM that is actually very similar to the application hosting that could run on a switch, for instance. And you can see that I gather important metrics about that specific appliance, and also along the many ways, the status of the test that agent is running against the applications listed here that I want to monitor.
So did I, as the NetBeez administrator, configure all of those tests that are running now?
Yes, correct. So you would create targets. In targets, we provide templates, or you can build your own custom targets. But the long story short is that with ping, DNS, HTTP, and traceroute, you have the building blocks to monitor any application or destination network. And then you push those targets to agents, and the agents start collecting the data.
Okay, so I build out targets and then say, hey, agents, I want you to hit this particular group of targets for, whatever my use case is. Got it.
Exactly. And then from that moment on, you have the real-time information up down to every second. As you can see, this is continuously feeding us with the telemetry data. And then I can see how that data changes. And then based on the alert profiles, I receive alerts if I'm having some sort of performance issue at this specific network location. So
you were talking about testing going as rapidly as every second. Where am I collecting all of these test results and metrics? Are they coming back to a central server? Are they going to the cloud somewhere?
Yeah, correct. So there is a central server that acts as a controller, and the server can be hosted on-prem or in a cloud, or hosted by NetBeez. So the server is really the brain where all the data, right, is collected, aggregated, and then displayed on the UI. Yeah.
So these agents are running all these tests against the targets, collecting metrics, and now I can observe. And when I'm seeing an alert pop up because something's out of spec, I can investigate.
Exactly, precisely. So real time is very important, but it's also important historical information. You can always expand, and go back with the data retention scheme even up to 2 years if you really want to do that. But the long story short is that you really have the real-time view into your network and understand if something is going wrong on breaking. Like, for example, here you can see that now we got a round-trip time increase from an average of 70 milliseconds, now a spike up to 200 milliseconds. So that, of course, then with an alert profile, you can generate an alert, a notification, and then look into what the problem is. The benefit of having multiple agents is that you quickly understand what type of issue you're dealing with, and whether this is an issue located to only one location or multiple location, which allows you really to do fault isolation into the problem. You can see, for example, now all this bunch of tests have turned orange. An alert was triggered, and then if I had any notification associated to that, I would receive an email or open a service ticket, and so on.
Right. And so from that view, it's easy for me to tell, is it the agent site that has the problem, or is it the target that has the problem? Just based on how that matrix is displaying. Yeah.
Exactly. So if I go back here to the bus, I see that now I have an open incident on this agent. And then if it was an application issue, I would see it as a target incident, right? For instance, like here, this CRM application, right? Mm-hmm. So our goal is really tell you immediately, is it the network, is the application? They turn a battle between teams sometimes.
Right.
And of course, real-time testing is not the only thing that we can run. We can also run hyperf, throughput tests, for instance. That's important to understand download and upload speed or site-to-site performance. And also there, if certain SLAs are not met, can receive, for instance, a notification via email or a third-party integration.
That's one of those annoyingly unexpected tests that you really have to run, because you can't count on getting the bandwidth that you're paying for all the time. It all depends on the network infrastructure and what's going on with the last mile and who you're sharing with your neighbors and so on, depending on the circuit type. So being aware of what kind of throughput you could get at a site really matters. That's an important test to be running regularly.
Yeah, it's good to monitor, round trip time, throughput, even MTU, if they change, the MTU, if you're going through, overlay and underlay network, some
Mm.
sort, yeah.
Okay, so we've seen infrastructure testing. You also do Wi-Fi testing?
Yes. So as I was saying, we have different forms and factors for the agents. One thing also we provide are small appliances for Wi-Fi monitoring. This is the latest one that we released. It's a Wi-Fi 6 and 6E. All that this appliance needs is really plug and play. So it's shipped to the user pre-configured based on their server location. And then all you need to do is plug it with an Ethernet, supports PoE if available, otherwise power supply. And then it reports to the dashboard, similar to this entry that you see here in the dashboard. And as you can see, these agents have two interfaces, the Ethernet and the wireless. Both can run testing. Of course, by default, only the Wi-Fi is used for testing. And you can see here at a glance, I can see understanding of the signal strength, what SSID you're connected to. And then if I scroll down, the performance of the agent on the wireless. This specific appliance is doing SSID hopping, meaning that can monitor more than one SSID in round robin. So it goes from one SSID to another according to the interval that the user configured, and provides you more coverage basically on your Wi-Fi availability and performance.
So I can cover every SSID that I've got out there. I would have set the agent up to cover the different SSIDs that I'm curious to know about the performance on. So what about things like competing SSIDs that are overlapping my channels? Can I figure that stuff out?
Yeah, you can. You can do an SSID scan and see what other networks are broadcasting at that location, and then verify if perhaps you have, a channel is busy. There are too many SSID, like in this case, you can see, based on also on your signal strength, link quality, and so on. Which in this case, it's pretty good.
But to speak to the probe, it's an SSID scanner as opposed to being like a generic air sniffer.
Right.
Generic meaning it's not doing spectrum analysis. It's
Correct.
interacting with the Wi-Fi systems in the area.
It's an active unit. It doesn't. It's not equipped with the spectrum analyzer, but it can support ad hoc packet capture, and it supports, hopping. I support all the three bands. So very simple. And then once you run the packet capture, you download the pickup, because sometimes there are some issues that need a pickup, a remote pickup. So instead of like having to drive out there, you have the sensor that can collect that pickup for you remotely. And another very important, I think, function for this sensor is the Wi-Fi connection timing, which gives me the time to associate, authenticate, even to a radius type of backend, and then gather a DHCP address.
Because there's a bunch of potential latency that's built into that, depending on what's going on with your Wi-Fi
Yes,
infrastructure.
exactly.
Yeah.
So generally, like a radius, the authentication phase is generally longer than you see here. Here we have a pre-share key, but in general you see it being 15 to 20 seconds. It really depends. And then also the DHCP, a typical issue, even in a guest network is DHCP is exhaustion if it's not well configured. Also, these sensors, one thing I want to add is that they can run scheduled tests. So they can run iPerf tests, for instance. They can do iPerf, TCP, or UDP. They can also run a speed test. Like any other NetBeez agent, they can run also path analysis, which is a good way to see ECMP networks and understand hop by hop how's the underlying network path to whatever SaaS or internet destination.
That's going across the internet too. You're actually telling
Mhm.
me what's happening as I traverse the internet, a public network, discovering the different network paths. Oh, and you've got directionality in there too, it looks like. So you can tell, like, if I've got asynchronous routing, would you be able to tell me that?
So to determine that, at best, you need to have endpoints on both ends. So it really depends
Oh, you
on
would,
how
yeah.
limited you are. But nevertheless, you can see the different flows, aggregated or disaggregated, and then understand really what are your SMP path and where there could be, performance degradation issues.
Very cool. Okay. So I can actually isolate what's happening on a public network that's not mine. NetBeez can tell me, yeah, there's a problem 6 hops up from you. There's a congestion point or something like that.
Right, precisely.
So going back to the Wi-Fi thing, Stefano, I just had a thought. Now, we were
Hmm.
talking about that hardware probe that you were showing off that gets me all the way up through Wi-Fi 6 and 6E.
Hmm.
Uh, I'm not shipping one of those to everybody that's working from home. Is there some way I can see what's going on with the average remote worker?
Yeah, exactly. So in 2021, we released the endpoint, which is one that I'm running on my laptop. And the endpoint are basically a lightweight network agent, which is what we call the appliances, whether hardware or software. And they have provide the same capabilities as any other network agent. So we have the real-time testing with the latency. It's very good to understand the kind of digital experience against a Zoom or maybe any other application that the remote user might use.
But again, this is a lightweight agent sitting on their MacBook or their Windows laptop, and it's just sitting there running in the background. And I can run tests from it? You said because it works like another agent.
Yeah, precisely. It works like any other agent. So you push targets, and then from that agent, it can run, network speed, it can run hyper test, and so on. And it also collects the wireless metrics, which it's very important, as remote users might not be wired connected to their router, and that's is one of the major issues that generally you deal with. Or they can also check VPN connectivity. So, for instance, if your users connect to the corporate network through a VPN, you can measure latency, packet loss across the tunnel, and understand if the problem they're experiencing is related with ISP, the Wi-Fi, or the local network or the application.
That's slick. Okay, and that's really important. I mean, you didn't say the magic words, but the magic words are digital experience monitoring, I
Yes,
believe, in today's marketing parlance.
exactly.
But that's what you're testing. You're actually testing to see what the user experiences from the standpoint of their laptop, no matter where they are. And it's nice that you can pull out specifically what's going on with their wireless. In that, I mean, I see this in my own setup. I've got multiple access points here in my house where I work from, and occasionally my laptop gets stuck to the wrong one, and my throughput on it is terrible. Now I live wired most of the time and don't notice, but sometimes yeah, that really matters. And you to be able to see that performance and understand what your signal strength was and those other metrics that give you a clue that your Wi-Fi signal at that endpoint is the core problem, is really helpful. Now, you're doing this. Oh, you're doing this proactively, though, aren't you? Because you're just running this in the background. So it's not like you're like, oh, I'm going to have to run a test to see what's going on, user, because you called the help desk with a problem. You're going to know ahead of time if they've got a problem before they've even called.
Yeah, correct. So this data is constantly running. Assume you have, your workforce, your employees running this in the background. Again, they're not consuming much CPU RAM, like 2% and 25 meg of RAM. So who cannot afford that nowadays? And you can be proactive. So certain employees might, cover customer-facing services of support, and they need to have a very good voice and video performance. So for those type of users, you can get alerts and then let them know that they're having some sort of issue, whether with the ISP, with the Wi-Fi, and so on. Or you can just, like, if you don't need to receive an alert for all the users that are having issues, but should they open a ticket, like could be the case of this user, then you have the data to understand what happened for that user at that specific point in time. So you can see here, this is the 24-hour incident timeline for this specific endpoint, like any other NetBeez agent in the end. And I
Mm-hmm.
can see that during this incident, I had ping packet loss, which caused the incident to open. And this packet loss was across all my application monitored. So in this case, I want to show you very simple. One thing I would look for, this user doesn't connect with the VPN, so I can rule that out. I can always check if there is, in this case, I don't have a network speed test, but if it was like my case, I can check the network speed test, if it was good or bad performance. Or it could be, in the case of that user, the wireless. So the wireless also here, I have the metrics and can tell me if the signal strength was very weak during that time period, or perhaps there was maybe noise, right? So for this specific case, you can see that during the timeline when that outage happened, we had a pretty significant drop in signal strength. not really an increase in noise, which tells me maybe the user walk away.
Yes, it looks like they walked away.
Yeah,
They headed away from the AP. Yeah.
maybe they had lunch, and there you go. So they actually had the two events if I extend the timeline. So maybe they had lunch, they were still working, and they were far away from the access point. Because if I would have seen noise increasing, then it tells me maybe it could have been a microwave on a 2.4 gigahertz network, perhaps that, or something else that caused interference with the remote user.
Okay, so from here, now you've mentioned a lot along the way about alerts and notification, and we talked right at the top about how alerts get bundled into incidents if there's a lot of them. Can I see that interface? I'm curious to know like how I define alerts and manage them and so on.
Absolutely. So the NetBeez settings, that's where you configure most of the kind of backend settings, such as the data retention. I was telling you, if you want it 2 years, so be it, right? Another thing is the anomaly detection. You can see they already have pre-populated some default rules based on the type of test that I want to attach those alert profiles to. Let me show you a bit the framework. So we have two types of tests, as I was saying, the real-time tests and the scheduled tests. The rules are pretty similar. We have the up-down loss of service, and then we have the performance baseline, where I compare a short-term average, say the 5-minute round trip time versus the 1 month, which I consider maybe my baseline. So I can say, okay, if I see my short-term average deviating from my baseline, then trigger an alert. And this is something that is more adaptive, because each network location may have its own performance based on geographically where they're deployed against certain application. Or you might want to enforce certain rules, such as the case of voice over IP. So for that, I want, for instance, packet loss not be more than even 1% in some cases, right? So I can set those rules, attach it to my test via targets, via the application that I monitor, and then this will rule the alerting.
Got it. Now you mentioned alerting. There's a bunch of integrations that work there, so I'm not. I mean, email, sure, but then there's a bunch of other systems you integrate with as well.
Yes. So outside email, we have out-of-the-box integrations with tools like PagerDuty, Slack, Teams, Syslog, SNMP, and so on. And most importantly, ServiceNow for lots of teams
Yep.
using ServiceNow to open tickets. So this allows you very easily to, and I would recommend always use incidents and not alerts to reduce noise. And if you want to be proactive, open a ticket or get a Slack notification in channel, and then you can really look at what the problem is.
Another kind of related to this, a little different but related. You mentioned API integrations earlier. So if I am a network automation shop, could I do an API call that would trigger a test and send me the results, and maybe I use that as branching logic for my operations?
Yes, so we support JSON-based APIs. Actually, for those who are interested, they can go to api.netbeez.net, and they can really gather all all these metrics from NetBeez, including the alerting, and feed that data into a third-party system or their own custom dashboard. They can also create targets or schedule tests even ad hoc through an API call if they want to do some routine operations. And then gather that data programmatically. So we see a lot of actually medium to large organization using a lot of the API and integrating NetBeez with their own tools or building their own custom dashboards for their own specific use case.
Oh, very cool. And one more question for you. I saw in passing IPv6 addresses show up on some of the interfaces. Do you have IPv6 support?
Yeah, we support IPv6. Agents report IPv6 addresses if they have those assigned. And then we can run, for example, ping IPv6 tests to check the performance, of a IPv4 versus IPv6 network. So actually, one thing I didn't show you is the target view, which is a very good way to see average performance of multiple agents or users to a destination, and then see that breakdown of performance from multiple locations.
Yeah, very cool. Okay, Stefano, this has been great. There's so much that this product does, and I've known you and NetBeez for a lot of years now, and we kind of lost touch. And then we had a briefing recently. And I was like, wow, NetBeez is doing so much. You guys have been in constant development in this product. It's really great. If people want to find out more about NetBeez, Stefano, where should they go?
Yeah, they can go to netbeez.net and take a look at the product specs and maybe request a demo, or just try their own trial, as we offer a 14-day free trial. So if you have your own Raspberry Pi or want to play with Docker or with the remote worker endpoint, feel free to request a free trial.
Excellent. This is great stuff, Stefano. Thanks again for joining us today on Video Bytes.
Yeah, thank you, Ethan, for having us.